Hi, welcome to IT Training Experts. This video tutorial covers the ICMP protocol. So what is ICMP? ICMP stands for the Internet Control Message Protocol. Not designed for data transmission, it was designed for troubleshooting. Used to test connectivity and reachability of devices on the network. Defined in RFC 792, the most common utilities associated with ICMP are the ping and traceroute utilities. So let's first take a look at the ping utility. The ping utility is used to test network reachability. In fact, it's probably the most common troubleshooting tool in IT. In fact, anybody that's been in IT for any period of time has probably used the ping utility. It's one of the first things we do when we start troubleshooting networks. It's available on most, if not all, operating systems. The name comes from active sonar terminology. So if you're familiar with submarines use a ping to locate objects in the water and determine how far away they are. So a little bit of a history lesson there with regards to ping. At a high level, how does ping work? So ping works by the local device sending an ICMP echo request to a remote device, and the remote device basically sending an ICMP echo reply. So it's basically saying, hello, are you out there? The local device, and the remote device replying back saying, yes, I'm here. It's measured in RTT, or round trip time. So that whole process we discussed above is measured in the round trip time. So let's look at the ping packet flow. So we have a PC at 192.168.1.100, and we have a server at 10.1.1.50. So at a high level, when you send a ping request, the packet looks like this. It's made up of an ICMP data field, which is a payload, an ICMP echo request, the destination IP address of 10.1.1.50, which is a server, and the source address of 192.168.1.100, which is a PC. It sends this out, the server receives it, and the server replies back, I'm here, with a similar packet, which has your ICMP payload, an ICMP echo response, which is the yes, I'm here, and a destination IP address of 192.168.1.100, which is the PC, and the source address now is the server, which is 10.1.1.50. So at a high level, that's how the ping packet flow works. So let's take a look at the traceroute utility. So traceroute is a little bit different than ping. Where ping, we're testing to see if a device is reachable, available on the network. The traceroute utility is used to display the path and delay between two devices on the network. So essentially, again, it's another troubleshooting tool. It's a little bit more advanced than the ping utility, but it's very, very helpful because if ping, let's say for example in a troubleshooting scenario, if the remote device doesn't reply with an ICMP echo reply that it's up and running, and that device appears to be down, we can use the traceroute utility to determine, is the device down, or is there a path or a hop within the network that is down, causing the issue. Traceroute has a couple of options. It's referred to as traceroute or tracecert, and those are commands depending on the operating system. Now this course or training video is not designed to talk about the differences between traceroute in Windows and Linux, for example. This is not an operating system specific course, but it gives you some ideas, or an idea that there are some nuances between the different operating systems. So that's one right there. Another one is traceroute, depending on the operating system, can be using ICMP entirely, or it could be using UDP, and it varies on the operating system. So for example, Linux and Unix-based systems use UDP, and Windows uses strictly ICMP. Unlike ping, it records each router as a hop on its journey to the destination. So you're tracing the route from point A to point B and everything in between. So let's look at traceroute from an ICMP standpoint. So we have our PC of 192.168.1.100, and we have a server 10.1.1.50. So let's say we send a traceroute with an ICMP echo request, a TTL of 1, and TTL, that's important, I want you to pay attention to that, we'll come back to that, and a destination IP address of 10.1.1.50 and a source IP address of 192.168.1.100. So this initial probe that's sent out has a TTL1. So what TTL stands for is time to live value. TTL is designed basically to give a packet a certain lifespan on the network. Without a TTL value, in theory, a packet could last forever, it would be infinite. So with this TTL value, it allows a packet at some point to die if it doesn't find its destination and be dropped. So in this instance, traceroute uses TTL to determine exact number of hops on the network. So in this initial probe, it has a TTL value of 1. But in this network diagram, we don't see it on here, but let's say there's a gateway of 192.168.1.100 in between the server and the PC. So when the gateway receives this ICMP echo request of a TTL of 1, it's going to reply back to the PC with a TTL time expired. And at that point, the PC knows that, okay, there's a hop there. So I'm going to send another ICMP echo request with a TTL value of 2 to the destination of IP address of 10.1.1.50 and the source address of 192.168.1.100. And that one reaches the server with a TTL value of 2, and the server replies back, I'm here, come back with a responding packet of basically a source address of itself, the server, the destination IP address of the PC, and ICMP time. This time it wouldn't be a time expired, this would be actually a reply in the original ICMP echo request. The big takeaway here is the TTL value. For each hop on the network, the TTL value will increment. So if it's 2 or if it's 10, it'll give you an idea exactly of the number of devices between your source and your destination. So let's look at traceroute from a UDP perspective. Very similar, but there's some important differences. So we have our PC of 192.168.1.100. We have our server of 10.1.1.50. So same concept. We send a traceroute. This time, instead of ICMP, we're using UDP port ranges of 334.34 and 335.34. And this is going to be incremented by 3 because typically traceroute sends probes in threes. And they're each going to have a TTL of 1. So in this example, like the last one, let's say there's a gateway or a firewall in between there. When this packet with the destination IP of 10.1.1.50 and the source of 192.168.100 hits the gateway, it's going to expire when that router or firewall processes the packet. And it's going to send a reply back and say, hey, TTL time expired. And so then there's going to be another 3 probes sent with the UDP port numbers incrementing by 3 again and a TTL value of 2. That one would, in this example, reach the server. When that happens, the server will send a packet with the source IP address of itself, the server, destination IP address of the PC. Instead of a ICMP time expired, it's a error there, it's going to come back with a ICMP port unreachable, because typically most servers or most computers, the operating system that runs on them aren't going to be listening on those port ranges. So it's basically going to say, hey, I'm here, but I'm not doing anything with these ports because these ports are reserved for ICMP. So it would send this packet back of a ICMP port unreachable. And at that point, the PC would know that there are basically 2 hops between the PC and the server. You have the first hop to the gateway and the second hop to the server itself. So that in a nutshell is how traceroute works. And again, like I mentioned before, the thing I want to reiterate again is the big thing is the TTL. That's always incrementing, and that's how it's using to tell the number of hops in the network. So let's look at the ICMP parameter type field. So type fields are used to describe the type of messages from an ICMP standpoint. They're defined by various RFCs. Some, quite a few are really not used anymore. Here's some examples. You got the echo reply, which is a type 0, destination unreachable is type 3, and echo request is a type 8, redirect is type 5, time exceeded is 11, and traceroute is 30. If you search Google, you'll find a whole list of these different types out there, and It's not something you need to memorize. It's typically used from a reference perspective. But a type, again, describes the ICMP packet, not only for the operating system, but it's also allows us to understand how ICMP is being used in that particular situation. And then we go into code fields. So code field defines the result of the type of message. So you have a type, think as kind of the parent, and then the code would be the child. So for each type, there's a subsequent code typically associated with it. And so in this example, there are 15 codes associated with the destination unreachable, which is type 3. In this example, you got the various codes: codes 3, port unreachable; code 4, fragmentation; code 13, administratively prohibited. And really, because destination unreachable is a pretty vague, message, the codes actually kind of give you more detail of exactly what happened, why was it unreachable. So again, just like with the types, there's tons of codes, and if you search on the internet, it's primarily not something you need to memorize. It's more for your reference. And that covers ICMP. So I hope you enjoyed this video, and look forward to seeing you again and seeing more videos from me here soon. Thanks, and take care.